Yes, hello. Good afternoon. So, this is our topic today. It's about exact differential equations. This is for those who did not have the exact differential equations topic yet because of some activities, intervening activities. And I'm going to tackle everything before you can do your homework video to explain the exact differential equations examples. Right. So the prerequisite to know exact differential equations is to know how to work on partial derivatives. So a partial derivative makes use of the symbol, all right? And it says here partial derivative of the function of x and y with respect to x, partial derivative of the function of x and y with respect to y. What does it mean? So I have here a function of x and y, 7x squared minus y squared, y to the fourth plus 5x to the fourth y cubed. Now, if I'm going to get the partial derivative of f with respect to x, the partial derivative of the function of x, which is this one, and get the partial derivative with respect to x, then x is a variable. If you say x is variable, then will be y will be a constant. Okay, so this is how it goes. Your x derive get the derivative of x, that will be 2x only, just for the x. And the 7 will stay in front of it because that is a numerical coefficient. Here, x cubed will be the variable. So you do minus 3x squared. You just copy your y to the fourth because that is a constant. When x is variable, then y becomes a constant, and other numbers. Also, n is a constant. Now, plus x is a variable. So x alone is 4x cubed. Copy the constants 5 and y cubed. So the answer here is the partial derivative of f with respect to x will be 14x minus 3x squared y to the fourth plus, you have to do a sequence of or order of constant x and y variable. So in this case, you can combine 5 and 4 together. That gives you 20x cubed y to the fourth. So this is the partial derivative of the function with respect to x. We're going to use the same function, f of x. Hello. I'm doing a video. Right. So we have the function of x, where is it? 7x squared minus x cubed to the fourth plus 5x to the fourth y cubed. Right. Let's write this down again. Seven x to the fourth, 7x squared, 3x squared y to the fourth, and x cubed y to the fourth, 5x 4 y 3. And that is x cubed y to the fourth. So this is the function of, what did I put as my definition? The function of f and x and y. All right. So this time we're going to get the partial derivative of the function of x and y with respect to y. If you say with respect to y, then y will be, y is your, may lamok. Y is your variable and x will be your constant. So with your numbers, that will be constant. Okay. So let's circle our variable. In this 7x squared, both are constants, so you have 0. Here, y is a variable, x is a constant. Let's differentiate y to the fourth first. So that will be y, 4y cubed, and then x cubed in front of it because that becomes a coefficient. Plus, your y cubed is a variable, so that will be 3y squared. 5x to the fourth will be a constant. So, the partial derivative of f with respect to y will be negative x cubed. The 4 should be in front of x because that is a constant, and we will follow the sequence of number x and y. Negative 4x cubed y cubed plus 5 and 3 will be multiplied together, so that will be 15 x to the fourth y squared. Right, so this will be the partial derivative of f with respect to x. Now let's go to the exact differential equations. So this is a question where we have to separate the dx and the dy's and compare them later. Now, this one, the 2xy squared minus 4 dx is actually your m, okay? M, and this is your n, okay? So, m, the partial derivative of m with respect to x, and the partial derivative of n with respect to y. Or the other way around, sorry. So, partial derivative of m with respect to y, okay, and partial derivative of n with respect to x. Now, what we're gonna do, we have to compare these two. If they are equal, then you say they are exact. So the first thing you have to do here is to test for exactness. Test for exactness. Right. So, partial derivative of m with respect to partial derivative of y of 2xy squared minus 4. Okay, so y here becomes a variable. X is a constant. So this will be y as a variable. You have 2y, and the rest will be constant. 2x will still be 2x. So partial derivative of m with respect to y will be equal to 4xy. X, 4 here I should say, will be 0. So we don't write it anymore in your equation. Now, next thing we have to do is to do partial derivative of n with respect to x this time. So let's copy it from here. 2x cubed y plus 3. 2x cubed y plus 3 dy. Okay, but dy will not be there anymore. Okay, we just get the expression. So the derivative of n with respect to x. Your x here is a variable, your y and number will be constant. So let's get the derivative of x cubed. That will be 3x squared. Where is it? 3x squared. So that will be, hang on, 2y, 2x. Oh, and the other one is, hey, what happened here? And that will be, copy the others, 2 and y. That's constant. So you have 6x squared y. Oh, they are not equal, right? So this one is not equal to that. Why is it so? So that will be, yeah, they are not equal. I think I had copied a wrong, hang on. Let me just change that to square because they must be equal. All right. Let's change that to square. Okay, sorry for that. 2xy squared minus 4 and 2x squared y plus 3. Let's change it. Okay. So if we square that, sorry for making this error. I did not copy it correctly. So let's do it again because I must get an equal differential equations. So if x is a variable, that becomes 2x. All right. And we copy 2 and y because they are variables. The 3 will become 0 because that is a constant itself. 2 times 2 is 4, x and y. So there you go. We have the partial derivative of m with respect to partial derivative of y must be equal to partial n over partial x. And we got for partial m that is 4xy, 4xy is equal to 4xy. Therefore, if they are equal, then we say they are they can be an exact differential equations. Very good. So after taking or after testing the exactness, then we can now proceed to the other steps. Proceed to other steps. Proceed to next steps. All right. What is this? We can take either the m or the n. Remember, these are the m and the n's. Okay? I'll take m first. Okay? 2xy squared minus 4 dx. So m is equal to 2xy squared minus 4. 2xy squared minus 4. And this is dx. So we have the partial derivative of m with respect to x. Let's take that one now. Divide everything by x. Okay? So what does it mean? It means that your x is a variable. So we're going to integrate. So next one is to integrate partial m over dx. Ano itong partial m over dx? That would be this one. 2xy squared y plus 3. 2x hang on. Hang on. I'll write that down. 2xy squared minus 4. So x is our variable here. Then if you integrate that, if you integrate that, if you integrate that, then you will have x squared over 2. Okay? The rest are variables. So you just copy them, 2y squared, and if you integrate f with respect to x, then you get 4x plus c. Okay? So let's continue. X squared over 2, that cancels out. You have x squared y squared minus 4x plus c. That's the partial integration of m with respect to the partial derivative of x. Okay, right. Now, after doing that, our next step, step 3, will be to differentiate. Okay, so integrate and then differentiate. Which one will you differentiate? This one. With respect to y this time. So get the partial derivative of m with respect to y. Kanina, we have integrated the partial derivative of m with respect to x. The third one is differentiate the partial derivative of m with respect to y as a variable. Y as a variable. So let's encircle y in here. There you go. And what's the partial derivative? That will be 2y. X squared is a constant. 4x is a constant, so that will be 0 plus c. From here, you can get c prime. So x is square, 2x squared y minus 0 plus c prime. I will not write 0 anymore. And this is the partial derivative of m. Equate this one, the partial derivative of n with respect to x, which is 4xy. Okay, hang on. Okay, here. Hello. So you have to equate it to partial n over partial x. 2x squared y plus 3 is equal to 2x squared y plus 3. Why do you have to equate it? Because we said that partial m over partial y is equal to partial n over partial x. Okay? So you have to get this one from the original equation so that you can get c prime. So this cancels out, that cancels out, then you will have c prime is equal to 3, right? And then step 4. Step 4 is to integrate c prime so that you can get c. So if you integrate that, c prime is equal to 3, integrate it, then you will have c back to c is equal to 3x plus, sorry, 3x only, 3x. There you go. We are now in our last part of the solution. Where shall we get that one? C prime is here. Okay. take this part. Sorry for that. Sorry for that. Okay. Then take that one. Okay. If you integrate a function, then it, for example, the function is f prime xy. If you integrate that, then it becomes f x y. Okay. So f x y is equal to 2x squared y plus c. 2x squared y plus c. Hang on. Let me see, where should I be? Oh, here. This one here. This one here. X squared y squared minus 4x plus c. Because we know what c is already. X squared minus 4x plus c. Sorry for that. X squared y squared minus 4x plus c. I hope you are still with me. I am scrolling up and down. X squared y squared minus 4x plus c. We know what c is from the fourth step, and c is 3x. We just have to substitute it here. So we have c is minus 3x. Therefore, our final answer will be the function of xy will be equal to a particular solution of the d x squared y squared minus 4x minus 3x. Combining the 4x and 3x together, then you will have the final, very final answer, sorry for that. Function of xy is equal to x squared y squared minus 7x. So this is the particular solution of our very long equation that says y 7x minus, oh no, that's not the one, I'm sorry, I'm confused. Okay, here, 2xy squared minus 4 dx, 2x squared y plus 3 dy. Okay, so we have eliminated the dx dy, and we came up to, there is differential calculus here because you have to determine the partial derivative, and then you have to integrate to get the c, and then you have to differentiate again to get c prime, and then you will write the final equation as so. And what is it? I hope you have followed it through. And this is it. That's the answer. Okay. So for your homework, I hope you have understood it. Okay. So for your homework video solution, you're going to do xy squared plus 2 dx and plus x squared y minus 3 dy. Okay. All right then. So all right, so I'm here. You have to do your homework, and I want to see that. Just send it to the GC through one of your classmates, yeah? And let's see how it goes from there. If you have any question, you can just do a comment down below, and I'm going to explain it to everybody through a video. All right, then, bye for now, and take care.